So boundary conditions for time varying field. So this is the topic we are going to cover today. So far we had studied about the relationship between electric flux density D vector, field electric field intensity E vector, magnetic flux density B vector, magnetic field intensity H vector using Maxwell equation integral form as well as in the differential form. That is differential form is point form. Okay. Relationships were studied. Okay, now we are going to study Maxwell equation for determining the boundary conditions of two different medium. Okay, so last class we had studied four Maxwell equation. Now, that equation will be applied only for the um, wave which is traveling in the same medium. ஒரே ஒரு மீடியம்ல travel பண்றப்ப தான் that four equation Maxwell equation will be applied. But while we are switching from one media to another media, so Maxwell, the same Maxwell equation will not be followed. Rather than that, we are going to use some other Maxwell equation for that. Okay, for determining that boundary conditions. Okay, so while switching from one medium to another medium, at the end of the medium, so boundary line. Okay, so that boundary surface conditions only we are going to learn. Here we are going to apply the concept on linear, isotropic and homogeneous medium. So first you consider the boundary between the medium 1 with the parameter epsilon 1, mu 1, sigma 1 and medium 2 with the parameter epsilon 2, mu 2 and sigma 2. So in general, the boundary conditions for time varying field. Actually, we are seeing the time varying field. That is nothing but the waveform, electromagnetic waves, which is going to be changing with respect to time period only. We are studying which going to be same as those for static field. Okay, so boundary conditions for static field as well as time varying field will be same. Thus, at the boundary, referring boundary conditions for static electric magnetic field, we can write the two conditions, that is tangential component of electric field intensity is continuous at the surface. So tangential component of electric field is continuous. Okay, அதனால தான் we are going to write it as a E tan 1 equal to E tan 2. So ரெண்டு மீடியம்க்கும் same. Okay, then tangential component of magnetic field intensity also continuous across the surface except for a perfect conductor. எல்லா மீடியம்க்கும் continuous தான் இருக்கும் magnetic field intensity. ஆனா ஒண்ணே ஒன்று, but that is perfect conductor. If it is here, second medium is conductor, then your magnetic field intensity will change. If it is not a perfect conductor, then it will be remaining same. Okay, so that you can write generally that H tan 1 tangential form of magnetic field is H tan 1 equal to H tan 2. But in the perfect conductor surface, the tangential component of magnetic field intensity is discontinuous. Okay, boundary la discontinuous இருக்கும். So that you can write the magnetic field tangential form of magnetic field as H tan 1 minus H tan 2 equal to some value, K value. Okay, so இங்க மேல பாத்தீனா H tan 1 equal to H tan 2. இத இந்த சைடு கொண்டு வந்தீனா H tan 1 minus H tan 2 equal to 0 ன்னு தான் இருக்கும். But here for the perfect conductor it is discontinuous, so that we are going to use some constant value K instead of 0 value. Okay, so third point, the normal component of electric flux density is continuous at the boundary if the surface charge density is 0. Surface charge density 0 இருந்தா மட்டும்தான் electric flux density வந்து continuous இருக்கும். The same thing will be followed for the second medium also. Okay, boundary cross பண்றப்ப the same will be followed, continuous இருக்கும். இல்லனா இல்ல. Okay, so அப்போ surface charge density 0 இருக்கிறப்ப உன்னோட electric flux density will be dN1 equal to dN2. Same for the first medium, for the second medium. N1 ங்கிறது first medium, N2 ங்கிறது second medium. சேமா இருக்கும். ரெண்டு மீடியமோட எலக்ட்ரிக் ஃப்ளக்ஸ் டென்சிட்டியும் சேமா இருக்கும். எப்போ சர்ஃபேஸ் சார்ஜ் டென்சிட்டி வேல்யூ 0 இருந்தா. இல்ல இப்ப சர்ஃபேஸ் சார்ஜ் டென்சிட்டி வேல்யூ இஸ் நான் ஜீரோ, என்னவாகும்? எலக்ட்ரிக் ஃப்ளக்ஸ் டென்சிட்டி வந்து டிஸ்கண்டினியூஸா இருக்கும் பவுண்டரியில. அப்ப dN1 minus dN2 equal to rho s. Okay, ஜீரோவா இருக்காது. So you are going to have some value that is rho s. Okay, the normal component of the magnetic flux. Electric flux muchtom at the magnetic flux density is continuous at the boundary. Here this has no conditions. Okay, இது மாதிரி surface charge density வந்து 0 ஆ இருந்தா தான் இப்படி இருக்கணும், continuous ஆ இருக்கணும் இல்ல. இது வந்து எல்லாத்துக்கும் continuous தான். So that we can write the Vn1 equal to Vn2. So only 4 components we are going to use. One is D vector, E vector, B vector, H vector. இது நாலு மட்டும் தான் கண்டினியூஸா நான் கண்டினியூஸா. கண்டினியூஸா இருந்தா எப்போ கண்டினியூஸா இருக்கும், டிஸ்கண்டினியூஸா எப்போ இருக்கும், அதுதான் நம்ம இந்த பவுண்டரி conditions for time varying field la paakrom. So both for static and time varying, the boundary conditions are same for the four component, that is D vector, E vector, B vector, H vector. Okay, either continuous or non-continuous. That's going to be learned in this boundary conditions.